Hello and welcome to another episode of Learn with Jabe. I'm Jabe Jabelson, and this week we are going to analyze your fantasy football season with Python. That's right, we're going to focus on every fantasy football owner's biggest arch nemesis, the ESPN projected points. Can you trust them? Should you trust them? Will you trust them? Together, we're going to walk through a Jupyter notebook with a bunch of code that helps you measure the difference between the ESPN projected points and the actual points scored each week in your league. By the end, you should be able to see who found and started overvalued players and who was a better manager who found all those undervalued players. Now, at a high level, we're going to use Python requests to get data from the unofficial ESPN Fantasy Football API. We'll save that data into a Pandas data frame so we can have some fun with it. And then we'll analyze and plot the data in different ways so we can get a feel for how teams fared with the projections. As far as prereqs, you're going to need an ESPN Fantasy Football League. Doesn't matter if it's public or private, mine's private. You're going to need Python on your computer. You're going to need Pandas, and you're going to need Matplotlib for some of the plotting. Now, I'll walk through everything in a Jupyter notebook, but I'll also link out to my blog post and GitHub repo so you can fork everything yourself. Before we jump in, make sure you smash that subscribe button. I got some big things planned for the year, and I don't want you to miss when another video drops. So without further ado, bon appetit!
All right, so analyzing your fantasy football season with Python, we're going to walk through the Jupyter notebook, cell by cell. I'm going to do my best to describe exactly what's going on. Again, I have a blog post if you want to go through at your own pace. And before we dive in, I want to give a special shout out to Stephen Morse. Has an awesome blog post where I was inspired and used a lot of this. He shares his GitHub repo, which I really, kind of forked over and adjusted for my league. And I'm going to show you how to adjust it for your league. Okay, so first thing we are going to do is import our requests and Pandas module. We always import Pandas as PD. Why? Because that's just what everyone does. Now, for the request parameters, there are really a few things we are going to need from ESPN.com. First, we'll need the URL, obviously, but then we're going to need this SWID and this ESPN S2, which are basically these authorization strings and tokens we'll use. And how you get them is what you're going to do is head on over to your fantasy league, go to your history, and within your history, you can go to a previous season, go to view scoreboard. And within that, you can click in, let's go to week 1, so we're not doing the playoffs, and go ahead and click into this box score. And so now you're going to have a score with all of the right projections and totals. You're going to go ahead and right-click Inspect and over to the Network tab. And make sure you have this fetch/XHR going. We can, let's just run this again. We're filtering on scoring, and you're going to see this first one that has what looks like the league ID and a scoring period ID of 1. Go ahead and click this request. Now here you'll see it's going to have the request URL, which we'll grab and use in a second, but it also has in these request headers this cookie section. And within this cookie section is where you got to go digging and try and find your SWID, which again is going to look like a long SWID code, and your ESPN S2, which is an even longer code that you need to copy. And once you have those, go ahead and put some parentheses around it. And we're going to go ahead and save those into variables so we can use them. We don't have to reference these big long strings. We can just use the SWID and ESPN S2 variables in the request parameters. So let's run that. Now, next thing you need is your league ID, which again, you'll be able to see up in the URL right there. It's going to be a private league likely. Most people play private leagues. And that's why you need to basically grant ESPN access to say, hey, I can get into this league. Here's my SWID and ESPN S2 authorization tokens that will allow you to do that. So go ahead and save your league ID into a league ID variable. Again, I picked the 2021 season, week 1, right? Week 1 box scores for the 2021 season. So I'll also save the season and this week variable into the season and weeks. And then lastly, this URL, right? I'm basically taking the URL, right, from this headers. Now, we only need everything up until, let's see, the matchup score. So we only need the URL up until this matchup score right here. So you would copy it over, and you'll see it has the API, the V3. Again, that changes sometimes when you go back into more historical seasons, but check out some of my other posts with help there. It's going to pass in this 2021, right, which is saying the season, and the week, the scoring period ID, which is 1. So that's saying the week 1 of the 2021 season with the league ID. So go ahead and grab that. And what we're going to do is basically remove the 2021 and the league ID and replace it with this format that passes in the season and league ID. So again, it just allows us to swap things in and out a lot easier. But again, you have that URL that is going to be up until that matchup score. And go ahead and run this. And now we are ready for our GET request, which is going to pass in the URL, the parameters, which we're saying, hey, we want the scoring period ID where it's week 1, and the cookies where for those SWID, pass in our SWID variable, for the ESPN S2, pass in the ESPN S2 variables. And then we want to read that response, the JSON part of the response. We'll save it into this ESPN raw data, and then we're going to print that. So we'll run that. And when we print this, this is going to be a big blob. You'll see here, big blob of a lot of information. A lot of information. Now, one thing to call out is if you actually go over into the response over here, we format this nicely, it should look nearly identical to this over here, right? This is the response that is using this information to make this page. Looks more or less the same. And then another fun tip is if we go into this preview, it actually allows us to kind of dive in, find some specific things which we'll use in the next section. Okay, so we know we want the projected and actual points, but there's additional information we're going to want to include in our data frame, such as the slot, right? You have these starters. You have the bench players. You want to know where they're slotting them in. This will be helpful for a few things we want to try. We want the player name, right? We want to know who is who. We're going to want to know the week, and we're going to want to know the season, right? So all of that is going to be information we'll need as column names in our data frame. So we're going to create this list of column names where we want the team. That's going to eventually be the fantasy team. The player, which will be the player name. The slot will be which position were they in the starting lineup, and of that was someone in a flex, the running back, wide receiver slot. The position, now that's going to actually spell out what it was because sometimes the IDs aren't as readable. And then the projected and actual points. So we'll run that. Now again, that big blob of JSON is going to be hard to get, but what we're first going to do is how would we get that team variable? So if we go back over to here, and within our kind of list of this preview, we'll go by one. So if I hit teams, it's going to unfurl. I don't exactly know it, but here are all of the teams in our fantasy league. We have a 12-team league, but again, it starts at index 0 and goes up to 11. So if I wanted to access that first team, I would pass in 0. The second team, I'd pass in 1, so on and so forth. So you see here, within that raw data, let's actually go within that team's, kind of spot, and then access that first team. And if I go and access that first team, we should see it has this ID variable, right, which is this ID key value. So it should pass 1 as the ID. Now, if I went to another team, we should see the ID counts up to 2, right? So we have these variables ID. So if I run this and I print the team ID, it should return 1 since I'm getting that first team in that list. Great. Now, referencing teams, team 1, 2, 3, 4, 5 isn't great. So what we're going to actually do is create a dictionary with the keys and then the actual names we want to call them. So I'm Jabe, I'm team 1. Gave you a few other names of members in our league. But if we go ahead and run this, and now we can basically replace the team ID, which was returning 1, tells you to go look up and see who that was and save that into the team owner entry. So if I now pass in 1 to the team abbreviation, it will look up, see Jabe, save it to team owner, and then print that name, which again, we see Jabe. Again, this will make things a lot easier to read later on. Okay, so each team, right, has a roster, which I will unfold, with entries. And these entries, 0 through 16, which are 17, are the players on the team. Now, this will differ depending on the league settings. You can see here, we start 10, have 7 on the bench. We actually play a 2 QB, but it's an offensive position as a second one in case there are no QBs, because sometimes people will hoard QBs on the bench. But this should map to your league settings. So within an entry, there's going to be a player, and we can get that through the player pool entry. And as we go down, we see here that there is the roster, the entries. I'm in that first row within the entries, and then I'm within the player pool entry, and then within that, I'm in the player. And now we start to get to something helpful of like, aha, this is Davante Adams. So if you were to go through, right, in that same team, into the roster, into the entries, and for each player in there, I print the player pool entry, the player, and the full name, right, which again, we have here the full name within the player, which should print Davante Adams. And now the other thing we're after is the lineup slot ID, which you don't have to go within the player. That actually shows up here, right? This lineup slot ID is 4, which we'll get to later. But go ahead and run this, and it should loop over all 17 players in your league, prints the name and the lineup slot ID, right? So 4 for Adams, 6 for Kelsey, 0 for Cousins, 2 for Swift. Now, similar to the team owners, that 4602 doesn't mean much. When we look here, I don't see anything that says 4062, right? We see the slots, the QB, the running back, the wide receiver. So we're going to map those lineup slot IDs to actual position names, where 0 is QB, 2 is running back, 4 is wide receiver, 7 is offensive position, which again, you might not have in your league, 20 is bench, and 23 is flex. So we create another dictionary, and we'll do the same thing where we're going to pass in that lineup slot ID to these eligible positions. And let's reprint that again, but this time including the lineup slot as well as the eligible positions. So now I see Davante Adams, 4 is a wide receiver, Kelsey, 6 a tight end, Chris Godwin, also 4, also a wide receiver. Okay, great. So now getting the projected and actual points, which is a little bit tricky. So let's go through one player at a time. So again, we're going to access that team. And within that team, we're going to access that first row of a player, which before, right, was Davante Adams. We'll get his name, and let's run this. We should see Davante Adams. Now, if we look over here, right, I'm on that player, we see this stats. So I open this, and I get this drop down of 1, 2, 3, 4, 5 rows of stats. Now, within the stats, there are a couple things we need to look for. One, we want to make sure the scoring period ID equals the actual week we're looking at. So scoring period ID should equal 1. The other thing we're going to look at is the stat source ID. Now, if the stat source ID is 0, then those are going to be the actual points. And if the stat source ID is 1, those are going to be the projected points. But we only want to look at these if the scoring period ID is also 1 and matches up. So let's look at this first one. Within those stats, we look and we see the scoring period ID is 0. That is not equal to 1. So that is going to be kind of this superfluous row we don't need. Let's go to the next one. The scoring period ID is still 0. Okay, so we're going to want to skip that, right? So in our code, we're saying if stats does not equal the week, which we had set as a variable equal to 1 earlier, then continue. So basically in that code, we just skipped over those first 2 rows of the stats. Now let's go to the next one. Scoring period ID still 0. So it looks like there's 2 left. Let's hope. Get to this next one. Aha. So scoring period ID equals 1. So we're now going to stop. And now we're looking to say if the stat source ID is 0, then take the actual points. And if it's 1, those are the projected points. So the stat source ID is 0. So we're going to go get the applied total, which is going to be the stats, right? So we're going to get in this applied total of stats and save that as the actual. So that will be 7.5 as the actual. Now there's one more here. Scoring period ID equals 1. Great, that matches up. Stat source ID equals 1, right? So we're going to go get the applied total, which is the 16.07, right? And since the stat source ID equals 1, then those are going to be the applied totals are the projections, right? So the actuals were 7.5, the projected were a little over 16. If we go look at Davante Adams, we see his projected points, 16.1, looks like they rounded up, but he actually only scored 7.5 in that first week. So let's go ahead and run this, and we're going to get the actual and projected for stats, which again should pull that same number we were seeing on the box score for week 1. So the actual we printed was 7.5, the projected was 16.07. Okay, so let's now do this for an entire team. So basically, we're just going to take what we did here, this stats, and we're going to do it. We're going to loop over all of the players on a team. And we're going to set the projected and actual equal to none each time. So it's not summing it up, but we reset it. And then we just run this exact same thing we did for Davante Adams, but now we're going to do it for every player in that team roster. And we'll do it for my team, which again was that 0, that first row. And if we run this, now we see, Davante Adams, 7.5 actual, projected 16.07. Kelsey, 22 actual, 13.8 projected. Let's just go get a gut check. Kelsey, 13.8, 13.9 projected, 22 actual. So it looks like it's working all the way down for everyone as far as Malcolm Brown and Chuba Hubbard on our bench. Fantastic. So we got it working, and basically all we're going to do now is loop over and do this for every team in that first week 1. So to start, we're going to have this empty list, which we're going to append all the data to. So we'll just have projection data. You can set it empty. And then we're basically going for the week in the range 1 to 15, right? So that's going to go all the way up to 15, but not including, which should take all of the weeks 1 through 14 in the fantasy season. We'll print that off so we know what's happening. For each of those weeks, we're going to pass it into that get request earlier, right? And that week variable is now going to be replaced where we were looking at 1. We'll start with 1, do it for every team, append it to the projection data list. Then we'll go to week 2, do it for every team, append it to the list. And again, we're passing in those SWID and ESPN S2 cookies, getting that raw data. And then all we're doing is all of those for loops of loop over for every team, right? Get the team ID so we can get the team owner name. We'll plug that into a column. Then for that team, get all of the players, and in the players, we'll get the player name, the lineup slot, and we'll use that lineup slot to get the position so it's more readable. And for that player, for the stats in that player, check if it matches the week. If it does, and the stat source ID is 0, get the actual points. If it's 1, get the projected points. And then all of that data, we're going to append to that empty projection data list. So if we were to run this, and at the end, we're going to print done getting projected and actual stats. So let's run this. You'll see week 1, week 2, week 3, week 4, week 5, so forth, so on, all the way up to week 14 and done. So now we have all of that information in that list. And what we're going to do is we're going to convert it into a data frame by calling this PD/data frame, where we pass in the list of data, that projection data, and we pass in the columns, right? The column names we want, which will match up exactly to the data for how we passed it into the list. And we'll save it into this DF data frame variable, and then we'll take a random sample of 10 rows. So we run this, and voila, you have the week, right? This is a mix of all 14 weeks in the regular season. You have the team name. So here I am. You have the player. So here was Jared Cook. Lineup slot 20, which is actually the position on bench. And you have the projected and the actual. Fantastic. Okay, now that we have all of this awesome data in our data frame, we're going to start plotting some actual and projected points for a team. So to do this, we're going to use Matplotlib. We don't need Seaborn. Messed around with it a little bit, just fine going with the old classic Matplotlib. Import that. And so what we're going to do is to start, if you remember those positions, we have the position 20, which is the bench. What I want to do is actually just get a data frame where I filter out all of the people, all of the rows where the position is in bench. And I'm going to save this to a new starters data frame. And I'm doing this because you don't really pay attention to your bench. I don't really care about the projections on the bench versus not for now. We'll get to an optimal lineup later. But let's just kind of compare starters across the board. And we'll do that by filtering everything into the starters data frame. Now, the last thing to kind of make things always easier, I run a fill na. If there is any nulls, we'll fill it with a 0. That should be helpful. This works more, or is probably more required if you include the bench, because there can be some injuries and various issues there. But after that, we'll sample. And what we should see is there should be no bench players in the positions, right? These are all starters now. And to do this, before we get into group bys, you can run this dtypes on the end of the data frame, and you'll see the actual and projected are both floats. Makes it easier to subtract. You want to make sure one of them is not an object, and that's also where sometimes this fill na will help. Okay, so what we're going to do is we'll pick one team. Now I'll go with Team Han, who was the 2021 champion, beat me in the finals. So we're going to filter down the starters data frame to where the column of team equals that one team. And we're going to save that into its own team starters data frame. Now, once we have that, we can take that and plot it. And what we're going to do is we're going to group by week. We'll take the projected and actual points and we'll sum it up. And basically, it's going to show the projected and actual points as two different lines on the graph, where week is the x-axis and the points are the y-axis, right? So the x-axis, we're going to plot the week. So when we run this, we get this graph of the projected points in blue from ESPN each week and the actual points in red. So you can see this team, didn't finish number one in the regular season, but did outscore the projections for the most part, outside of this, 3-week period where maybe he was struggling with some injuries, kind of a 4 out of 5 weeks. But for the most part, pretty high above the projections. You see the total points, 150. Looks like ESPN really thought his team should average around 130, again, until something happened here later in the season. Now, what we can do is take all of this code and create a function so we can plot that for any team we want. So basically, all we're going to do is take this, plot it into this plot team function, which we'll define. It will take in a data frame and the team name, right, from that team abbreviation dictionary we had earlier. And we're basically just going to replace the team name that we did before with the variable. So we'll filter all of that, save it into a data frame, and then plot everything there. So we now have this function plot team, and we'll run it for that starters DF, and we'll plot my team. So again, I finished second. Hot start to the season, right? I was scoring a 160 in 2 out of 3 weeks. Also struggled a little bit here. Maybe that was just a tough scoring across the league. Came back hot and was able to make it all the way to the finals, but ended up losing, unfortunately. Okay, so plotting, fun. Let's also try and quantify the difference between the projections and actuals. So again, we'll create a new function, calc difference, that takes in this data frame. And all we're doing is taking the projected columns, summing it up, and the actual columns, summing it up and subtracting. Now, since we're subtracting from the projected, that means negative is good here, and positive numbers are bad, right? Like if you are projecting 120 and we're subtracting 100 actual, you're gonna have a positive 20. If you were projecting 120 and your actual was 140, you'll have a negative 20. So negative is better here. So we have this calc difference, we run it. Now we can do the same thing, take the starters DF. Let's group by team, and we're gonna apply this function to each of those teams, and we'll save it in this team DF. And then I'm just kind of passing in some fancy pandas plotting to make sure it shows everything within Jupyter Notebook. And I'm going to round everything to 2 so we don't have those kind of long projections earlier. So if I print this now, you'll see teams that were negative, basically ESPN was undervaluing them, or their players were just going off. And the teams that were positive, ESPN thought they had good players, but it doesn't look like they did. Now, this is kind of hard to read. Let's sort the values of this so we can actually go best to worst. So again, it looks like this team, Bill's team, always outperformed over the course of a season. The projections, whereas a few of these folks were pretty low. So you'd imagine these are some of the teams that make the playoffs and do well. These are probably some of the teams that struggle a little bit. So that's fun. We could take it one step further. We could group by week, the team and then the week, the team and then the position, and the team and the player, and get those differences. So let's run this, and then we can plot again the first one. So this is by week. So basically you could see, okay, which weeks did the teams do well, which weeks did some of the teams struggle. So again, before, if we look for mine, I was at the top. There I am, right? Coming in hot, missed it for a few weeks, and then ended the season well. Again, if we do by position, so on my team, it looks like my QB outperformed nicely. So did my running back. Again, I think that was a specific player. And we can also print the one by player. So again, let's go find mine. We saw here Leonard Fournette minus 45. ESPN just couldn't get a handle on how good Lenny was in 2021 season. So again, if you want to just look at your own, you can filter down everything to just that one team name and then group by player. So this is just for my own, and I'm sorting the values. So these were some of my undervalued players. These were some of my overvalued players. Now again, Kelsey was still a beast that year, as was Mike Williams. ESPN just couldn't get a handle on how to project them. All right, if you've made it this far, we got a bonus section where we go into Stephen Morse's code from his GitHub, which again, big shout out to him. This blog post, which again walks you through how to really measure some of the roster skill. And what we're going to do is just modify the code slightly to adjust for my league settings. And if you follow along, hopefully you can do the same for your own league. So first things first is we need all of those slot codes. Now you'll notice a few things to where, because you can have multiple of these players on a roster, you can have two slots. So since I have two wide receivers and two running backs positions and two QBs, you need to have those additional slot codes because you might start two running backs, but you need to know in which position. So create this in that same mapping of a dictionary. We'll run that. And now what we're going to do is kind of similar to everything. He put everything into these nice functions. So first we're going to get matchups. So for each week, we need to get what the matchups were. So you'll see we're getting this matchup score variable. So it's basically that URL, including the matchup and the matchup score. We're passing in that same, kind of scoring period week. And then the matchup period week is new, but we'll also include the cookies with everything we need there. He's kind of passing in a different way, not the format, but the string of the league ID and the season. So we're just going to have this function get going. Then you have the slates, right? And he adds some nice description here where it's basically the slotted position. It's getting the actual and projected points for each of those slates. So again, very similar to what we have. And, kind of, again, you want to adjust to what you have in your league. And we'll go ahead and keep a lot of that slot ID and slot info the same. But this is more or less getting that slate data. So we run that. And then once you have the slates, it's going to be a function to compute the points. So this is where you need to pay close attention as well, as like you have slots per position in your league, right? You can only have one QB, two running backs, two wide receivers. So you're going to need to adjust this, but this is basically getting the actual and expected points for each of those. And it's filtering out all of them in the bench or on IR. I didn't have IR, but I kept it because it wasn't making any difference here. So you have those compute points. And next you have the team names, right? So again, he's getting all of the team names, saving them there and returning. And then what we're going to do is we're going to plot the actual and projected data for a given week. Now, this is a little bit more advanced, but really, let me show you what the output is. And a couple things to call out is if you're not doing the optimal, we can actually get rid of a lot of this data. We'll get to that in a second. But all it's going to do is take for a given week, what were the actual and projected points for ESPN, and then match it up, right? We're looking at now a specific matchup to see who ESPN projected to win that matchup and what actually happened. And then we're going to bold the winner, and we'll kind of show each of the 6 matchups for a given week. So You'll get down here, and this is where now we have all those functions set, and we need to give the actual information we plug into them. In this case, we're going to pass the league ID as an integer because, again, what we have in this code is actually the league ID will be turned into a string. We are going to have the season, same thing, start as an integer because it will be turned into a string. We'll do this for week 1. This is to where you need to match your positions to your league. So we had a QB, an RB, a wide receiver, a flex, a tight end, the defensive special teams, a kicker, and an offensive position. And then you need to match the structure is for that first one for QB, how many could you have in that spot? 1. For RB, you would have 2. For wide receiver, you would have 2, and then 1 for each of those other positions, right? So this should match exactly the slots you have here, right? I have 1 offense position, 1 QB, but I have 2 running backs and 2 wide receivers in my league. And then what we're basically doing is just running through in order. We want to get the matchups. We save it into that variable. We get the slates for those matchups. We save it into slates. Then to compute the points, we pass in the positions and the structure and the slates. And then we get the team names by passing in the league ID, the season, the week. And to make things easy, let's rename the teams. Oh, sorry, let's make sure we run this one. And then we're going to plot everything and show it and watch this magic from Steven. Aha. So for week 1, we have the actual points and the ESPN projected. So you see here, what's the point? Scored just under what ESPN projected. And Riley Boo scored just over what ESPN projected on these points. It looks like about 110, and that's the 120. If you go to our matchup, the Timo Stanton and Jabelson, ESPN projected I would score about 125 or so, it looks like, and I scored, 155, whereas they thought my opponent would score about 118, and they scored less than that. Now let's confirm. If we go back to this week 1, ESPN projected I would score 124, I scored 152, and they thought my opponent would score 113, and he scored 93. And again, this is just a different way to plot that. Now you can change the week, right? You can change the season. Now, the super extra bonus one is factoring in the optimal lineup. So what this means is let's layer on an additional piece of information of if you played the perfect lineup, how many points would you score that week? So we're going to go ahead, and the only thing we're going to change is this compute points. We're going to add back in this O points, which is these optimal points. And basically the difference here is it's going to check the positions, right? And the flexing is going to be the hard part, as knowing, okay, take the highest number for a given position, slot them in. After that, go check the next highest position and slot that in, but also factor in the flex. Now, the tricky thing for us is this is for flex. If you play with an offensive position, you need to add in this QB because QBs are eligible for that offensive position. Defenses, kickers are not eligible for the offensive position. But for that flex, it's basically going to go ahead and slot in the highest RB1, RB2, do the same for wide receiver 2, tight end, and then in that flex position, it's going to look at all of your wide receivers, running backs, and tight ends and get the highest points from those other players. And then do the same thing again for us, the offensive position. And so we're adjusting that in this compute points function. We'll run that. And then when we're plotting, we're basically going to include everything he had to where it's going to add an additional little bubble for the optimal points. Now, if we go ahead and plot that same graph, you'll see the best possible. And he also added something as far as the difference between the best possible and the actual, right? So there was a chance the Riley Boos lost week 1, but had they played their best possible optimal team, they actually would have won. So they left a lot of points on the bench. Now, if you look, you see I still left some points on the bench, which again, if we go to that week 1 box score, we can see where did I leave those points. It actually came because I started Ben Roethlisberger in my offense position, and I had a chance to start Carson Wentz, which would have given me an additional 9 points, right, and put me in that 161 range. So this is, again, a super fascinating way to look at it. Well, there you have it. another episode of Learn with Jabe, where we walk through how to analyze your fantasy football season using Python. As always, smash that subscribe button as I got more videos with more fun side projects this year. And until next time, I bid you adieu.